The very heartbeat of the operating systems of this building. We're in the mechanical room of the Science and Technology Center. Few people actually that work here would ever have reason to come in here. But as I said, it is the heartbeat, and it's a good place to talk about this fourth point of innovation and design that we mentioned earlier. Now what we have here is the air conditioning system, which in part consists of a machine that cools water down to a very low temperature. We take that water, we pump it to the roof, and then we move it up there on the roof, we move it through a set of pipes. And as it's moving through the pipes, we use air handlers to pass air over those pipes, cool down the air, drop that air into ducts, and that's how we cool the building in the summer. In a similar way, we bring steam in, we put it into a tank, heat up some water, and then move that water, just as we did the cold water, to the roof, move it through pipes, air comes over the pipes, drops into the ducts, we heat the place as we're doing now. Now neither of these two particular systems are, as I've described them so far, are particularly innovative, but we do some interesting things with the byproducts of these systems that you won't see in typical buildings. I'll start with the cooling system, and then we'll talk about the heating system when we get upstairs in the labs. Better setting for it. But in the course of that cold water moving over the pipes, or through the pipes, and the water going, or the air going over the pipes, we create a condensate. We create water, much as you see water on a soda can on a hot summer day. And then the question becomes, what do we do with that water? Typical buildings will dump that water into a storm drain, and it will go to the same place that the rainwater goes. It's wastewater. We do not treat this as wastewater in this building, because when that condensate leaves the area where it's harvested, it goes through a set of pipes, and it will in turn cool down some return water that this machine is about to cool down. And essentially this, by the time that water gets here, it doesn't have to do, this machine does not have to do as much work, because the water is pre-cooled by the condensate water that happened to be around up there, and we gathered it up and it serves the purpose. But we're not done with that water yet, because then we move it on into the cistern that we talked about much earlier, and it joins the water, the rainwater that came off the roof. And then some interesting things begin to happen, because what we'll do is, out of that cistern, we will not only service the toilets and the industrial uses that we discussed earlier, but we'll also pump some of that cistern water into the cooling tower, which is a part of this air conditioning system. And when we do that, we find that the evaporation of the water in the cooling tower, the blow-off of that cooling tower, equals about 1.3 gallons a minute on a typical summer day. And guess what we're manufacturing over on the other side when we got that condensate water in the first place? The system will generate 1.3 gallons per minute in the process of generating this condensate water. So essentially, we're manufacturing water over here, and we're using it over here to make up for the evaporation and the blow-off of the cooling tower. We'll talk more about the heating system when we get to the labs, which will be next.